In today's lesson, we'll be learning about geometric sequences. We already learned about arithmetic sequences and using a common difference to get to the next term, and in today's lesson will be very similar with how we've worked with those arithmetic sequences, but we'll have a few differences. For geometric sequences, we're going to learn that a geometric sequence uses a common ratio, or the same value multiplied to each term. We'll learn how to find the explicit rule of a sequence, which was similar to what we did with the arithmetic sequences, and we'll learn how to find the nth term of a sequence. So first, geometric sequences use what's known as the common ratio, noted with an R. The common ratio is a value that is the same value that's multiplied by each term to get to the next term. So geometric sequences multiply the same value to get to the next term, and that's known as the common ratio. So let's look at a few examples of geometric sequences and see if we can identify what the common ratio is. In this first example, we have the sequence 2, 4, 8, 16, and 32. You can probably see that with this sequence, we are multiplying by 2 to get to each next term in the sequence. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 gets us to 16, 16 times 2 gets us to 32. So R for this sequence, the common ratio, is 2. In our next sequence, we have 9, -3, 1, and -1/3. In this sequence, I see that the terms are alternating between positive and negative. So I know that we are multiplying by a negative number. So keep that in mind. If you see a pattern like this where it's positive, negative, just know that you're multiplying by a common ratio that is negative. I can also see in this sequence that my numbers are actually getting smaller. So it's kind of like we're dividing. But dividing is the same as multiplying by the reciprocal. So we just want to make sure we use the multiplying value, not what we're dividing by. But you can use division to figure out what that common ratio is, but then change it so that you're multiplying by the reciprocal. So if you think of it as dividing 9 to -3, that would be like dividing by -3. 9 divided by -3 gets me -3. But in terms of multiplying, that would be like multiplying by the reciprocal of -3 or multiplying by a -1/3. And then -3 to 1, that's like -3 divided by -3. But as multiplication, we're multiplying by that reciprocal. So multiplying by a -1/3. And this last one, 1 times a -1/3 gets us -1/3. So in this case, our common ratio is a -1/3. So just remember, you can use division to help you come up with what that common ratio is, but write it in terms of multiplication. So write it so that you're multiplying by the reciprocal. So whatever you are dividing by, change it to the reciprocal so that you multiply. And our last sequence, 5, -10, 20, and -40. I again see this alternating positive, negative pattern, so I know that my common ratio, I'm multiplying by a negative number, and then 5 to -10, well that's times by a -2. -10 to 20, also multiplying by a -2, and 20 to a -40, multiplying by a -2. So the common ratio with this last sequence is -2. We are multiplying by a -2. So let's look at using this common ratio with our geometric sequences. See if we can identify the common ratio and come up with the next 4 terms. So here's our sequence. We have 1, 6, 36, and 216. With a common ratio, I know I'm multiplying by the same number. So 1 to 6, I would multiply by 6. 6 to 36, also multiplying by 6, and 36 to 216, I'm multiplying by 6. So my common ratio is R equals 6. To get to the next 4 terms, my next term, 216 times 6, you end up with 1,296. So 1296 is my next term. If I multiply that by 6, you end up with 7,776. Multiplying that term by 6, we get 46,656. And our final term that we wanted to identify gets us to 279,936. So you can see with geometric sequences, your sequences, the numbers get very large very quickly because you're multiplying by a number to get to the next term. So just keep that in mind. Your geometric sequences are going to get very large very quickly or very small very quickly, depending on what your common ratio is. Let's look at another example. In this geometric sequence, my sequence is 3, -15, 75, and -375. So right away, I want you to notice that there's that alternating pattern, positive, negative, positive, negative. So I know that my common ratio has to be negative. That's the only way to change signs, because a negative times a negative is a positive. So now looking at this, 3 times something to get to -15, well, I could multiply by a -5. But then check your other terms. -15 times a -5 also equals a positive 75. And 75 times a -5, you end up with -375. So the common ratio for this geometric sequence, we're multiplying by a -5. So our next 4 terms, if we start with this -375, and we multiply by a -5, since it's 2 negatives, my next term should be positive. And we end up with 1,875 for our next term. We want 4 terms, 4 additional terms. So we're going to multiply that by our common ratio of -5. And we end up with -9,375. Multiplying that term by our common ratio of -5, you end up with a positive 46,875. And to find the last term, again, multiplying by our -5 for our common ratio, you end up with -234,375. So similar to what we did with the arithmetic sequences, we can use those same vocabulary words, those same assignments with those variables, and come up with an explicit equation to use with this geometric sequence to find any unknown value in that sequence. So just like arithmetic sequences, each term is given a value. So in our sequences, when we had the sequence 2, 4, 8, 16, our first term is a sub 1, our second term was a sub 2, our third term was a sub 3, fourth term was a sub 4, and so on. Same it goes with geometric sequences. So a sub 1 represents our very first term. A sub n represents the unknown term, the one that we're trying to find. N is our term number. So for example, if we wanted the 15th term, n would equal 15. And then a sub n, we'd have a sub 15 for finding the 15th term. And we already know r. R is the common ratio, so the number that's multiplied times each term. The explicit rule equation for geometric sequences is similar to arithmetic sequences in that we identify the first term, we need the common ratio, and we have the term number minus 1, but notice how it's set up a little bit differently. In a geometric sequence, we have our common ratio raised to an exponent. That's important. The arithmetic ones were not to an exponent, but geometric is. So using this with an example, to find the explicit rule for a sequence, we need to identify the first term, and we need to identify the common ratio. So in this sequence, our first term is 1. So we're going to use 1 in place of a sub 1. And our common ratio, 1 times something equals 4. Well, 1 times 4 equals 4. 4 times 4 is 16. 16 times 4 is 64. So our common ratio is 4. So then setting up our explicit rule, we're going to replace a sub 1 with 1, because that's our first term. So 1 times our common ratio of 4 raised to the n minus 1 power. And you can actually simplify this since we're multiplying by 1 as a sub n equals 4 to the n minus 1. This is our explicit rule for this sequence. So now that we know the explicit rule for this sequence, we can use it to solve for an unknown value. So our same sequence, if we want to find the eighth term in this sequence, we're going to replace n with 8. So using our simplified version, we had a sub n equals 4 raised to the n minus 1 power. So a sub n equals 4 raised to the 8 minus 1 power, because I want to find the 8th term. So I replace n with 8. So that a sub n equals 4 to the 7th power. If you know exponents, this means 4 times 4 times 4 times 4 times 4, 7 times. So 4 to the 7th power, when you multiply 4 times itself 7 times, you end up with a sub n equals 16,384. So this is the 8th term in this sequence. Let's look at one more example. If we want to find the explicit rule for this sequence, this one looks a little tricky because when you notice in the sequence, we've got fractions. But remember, with geometric sequences, we can kind of use division to find what the rule is, but use multiplication to write it. So in this case, 8 to 2, think of it as 8 divided by 4 equals 2, but you want to multiply by the reciprocal. So we're actually multiplying by 1/4. So our common ratio, we multiply by 1/4, and our first term is 8. So writing our explicit rule, we would have a sub n equals 8 times 1/4 raised to the n minus 1. And you don't want to multiply 8 times 1/4 first, because you want to use order of operations and do 1/4 raised to the n minus 1. So let's identify certain terms in this sequence. If we want the 6th term in this sequence, we replace n with 6. So a sub n equals 8 times 1/4 raised to the 6th minus 1. So 8 times 1/4 raised to the 5th power. Think of that as just being 1/4 times itself 5 times. 1/4 times itself 5 times is 1 over 1024. And this simplifies to 1 over 128. So this would be the 6th term of this sequence. And to summarize for what we learned today, we learned that a geometric sequence uses a common ratio, noted r, which is the same value multiplied to each term to get to the next term. We also learned how to develop the explicit rule for a sequence by using the equation a sub n equals a sub 1 times r raised to the n minus 1, where a sub n is the unknown term, a sub 1 is the first term, and r is the common ratio. And then finally, we learned how to use that explicit rule of the sequence to find an unknown term by replacing n with that term number.